Hello everyone. I'm actually going to be doing some hacking, not necessarily hacking, but I was doing some exploration work on the Spanner client library, and I've just published an article on the transactions, so I think that maybe I can demonstrate some of the topics that I've been talking about because they're very hard to digest. And you need some practical examples in order to understand any of those concepts. I'm trying to make sure that my stream is doing well because some people are watching, and please say hi or something if you can hear me. I don't have my headphones on, so I can't see if I have any audio. Someone's saying hi. Okay, great. It seems like people can hear. So going back to my screen, Spanner has a Go library. It's actually very well documented. This client library has been around since 2017. It explains a lot of things in the Go doc, some of the core concepts. Starting from the basics, like how to create a client, how to do simple reads and writes. It explains some of the concepts like keys, key ranges, that sort of stuff, as well as transactions, and so on. It is kind of hard to read actually because you see that there's not much of a structure maybe, but I can explain maybe some of the core concepts here. If you would like to use this library, I think you have to know first how to create a client, which is important, and then most of the people will need to learn how to apply some mutations. We can come back to this later. And then the next thing is transactions. So all the reads and writes actually happen inside the transactions, and you have to learn about transactions. There are two types of transactions. The first one is the read-only transaction, and the second one is the read-write transaction. Read-only transaction is only for reads, and it's lockless, so it's really good for performance if you just want to read. But if you need to do writes, you have to use the read-write transaction. And there's this other transaction type called single reads. This is some sort of an optimized version to do some strong reads, which I will explain later what they are, and it's recommended if you just want to do a single read. This must be also a read-only transaction, so it returns a read-only transaction which is slightly more optimized to do some stuff. So you basically can, on a transaction maybe, I can show you from the API what you can do. You can run some you can run queries, you can read, you can also submit some mutations. So in Spanner, read-write transactions doesn't apply the write when you are still in the transaction. You have to commit the transaction in order for the writes to be visible. That's why in the API, you don't actually write, you buffer some writes. I'll show you how that works. You just read, you create a read-write transaction, which allows you to just basically specify this block, and it could be anything. And if you need a transaction, it means basically you have to do a bunch of reads and a bunch of writes. And in this case, they are reading a row and then updating some stuff based on what's been read. And if you take a look at this line, this is actually not really updating. This is creating a mutation, spanner.update is return a mutation, and then you buffer that write. And when this transaction is being committed, this buffered write is going to be written, and if it fails, the entire transaction fails. So you won't be able to, if you do another read after this line, you won't be able to see the updated balance because this write hasn't been done yet. But after this transaction is completed, you can see you can see the value from another transaction. So this is the sort of like things that I've been looking at. Understanding the isolation levels and transactions in Spanner is really important to understand the whole big picture. And I think Spanner is like diverging a lot in terms of like isolation characteristics, and as well as some of the like trade-offs. And you know, the SQL spec has a bunch of like, you know, standard isolation levels, as well as there's like very well formed ACID properties, and maybe understanding like what Spanner does in terms of those stuff is a good way to understand how it works at all. I just published something like earlier today about transactions. I started this blog to just kind of like take notes for myself. If you want to learn more about Spanner, you may actually take a look at this. I'll probably share more. And there's a question about my grayscale filter on my webcam. So on OBS, there's a way to apply LUT files. LUT files are color profile, and you can basically just use any video or image editing editor to create your LUT files. I published some of my LUT files here on my GitHub just recently. I'll share the link just in a second, but they are here. So you take this file, save it on your machine, and then search on Google or on YouTube how to apply LUT files on OBS, and then you can get similar results. I think the best color profiles are profiles that you optimize for your particular input, but this grayscale ones should work well. I also did some like leveling because of my light and so on, so it might be good to maybe use these as a reference point. But yeah, like you can also work on your own profiles. It's a little bit work, but I think I have nothing to do at home right now, so it's really cool. I needed some sort of distraction from news and everything, so yeah, I was working on color grading. It's also I just want to generally, like, I have so much footage from the city and so on. I just want to produce some other stuff, so I think it made sense to spend some time on this stuff. Going back to Spanner, I just published like some of my notes because I've been doing some reading, some prototyping, as well as was talking to a lot of people. Even though it's virtual, I think I learned a lot. So one of the interesting things about Spanner is like you don't necessarily care about like, replication, you don't care about sharding. These are all done by Spanner. But you still have to can care a lot about like some of the other characteristics. As I said, there are two different transaction types: read-only transaction and read-write transactions. Read-only transactions is basically reading from a particular timestamp. By the way, Spanner is a version database, so it contains all the versions of everything up to an hour on the Google Cloud Spanner product at least. And you basically can go back in time and read a particular version from that timestamp. And read-only transactions are very cool because you can. It's basically reading back in a particular point. And just because you are reading in the past, it means that like your reads can be lock-free. Read-write transactions, on the other hand, are like allow you to buffer some writes. And here I have a snippet. You don't actually write in the transaction. You create a mutation, and then you buffer that mutation, and then when this block is executing, it will try to mutate the mutation, and if it fails, it's going to fail the entire transaction. Otherwise, If all the writes succeed, the transaction is going to succeed. As I said, like, I think maybe looking from like the perspective of ACID properties might be good, because, you know, ACID is some sort of like a standard expected things from a DB. And so you, as an application developer, don't have to deal with like database problems, and make sure that your database is handling those problems. Some of the, like, you know, easier concepts like atomicity, for example, you know, all the transaction, like all the stuff in transactions should either fail or succeed. Like, it shouldn't be the case. Some of the writes fail and some of the writes succeed in a transaction. In order for a transaction to succeed, like all the writes should be successful. Otherwise, the transaction fails. That's how Spanner satisfies things. Consistency, this is a really huge issue for Spanner. Like, huge issue is in terms of like it's actually doing interesting things, and it's really consistent. So one of the key characteristics of Spanner is like it allows you to see the same data everywhere globally. As I said, it's like doing global. It's a globally distributed database, but also it promises you, if you do a strong read, to see the same data everywhere. And I'll explain more on that. And then for isolation, this is an interesting topic because Spanner doesn't have like typical isolation levels that like other traditional noodle databases have. It actually provides like something stronger, and I'll get back to that. But also, you know, to recap, for read-write transactions, you know, it returns all the reads from a particular stamp. If anything is mutated and that was read in the transaction, that transaction is going to fail. All the writes have to be committed for transactions to commit. So all the writes in the transactions are only visible once a transaction commits and succeeds. The similar read characteristics are also true for read-only transactions. You have to read from a particular timestamp. And as I said, like, these are lock-free, so it's really good for performance. I've been talking about this strong read versus something else. Like, there's a concept called strong read. Strong read is reading the latest value. Like, think about it as like the latest value. So when you make a query or some read to Spanner, it first figures out what is the closest replica, and then in that replica, you have two options. You can do a strong read. In that case, it's going to go and ask the primary if the data is still the latest, and if yes, it's going to return. In the other case, you can make stale reads. This is really nice if you don't want to do that like overhead thing. If you are looking for more performance. And if you don't care if the data is stale or not, like, for example, if you're running some stats on your data by just reading and like just piping it to another system, you can do stale reads. And it allows you to actually like set the staleness. For example, you can say, hey, I just want to read data, but it must be like 1 minute stale. Or you can say like maximum it must be like 10 seconds old. There's like a bunch of different options you have. So here in the API you see that like there is 5 different options, and exact staleness is like, hey, I just want the data like 30 seconds ago, for example. Maximum staleness is, hey, like up to 30 seconds I can handle stale data. Or you can provide a specific timestamp, or you can do the strong read. And the strong read, it just makes, you know, just kind of like asks the primary again, like, hey, if the data is stale or not. If it's not stale, then it returns from the replica. Otherwise, you have to wait. So yeah, I said isolation levels, and I also tried to briefly explain, like took some notes. I'm definitely not really at this point like knowledgeable enough to explain all the underlying concepts here, but at least there are few things that I can explain. The first thing is like the SQL, like the standard, you know, isolation levels. From like the lowest level to the highest, there's read uncommitted, which means that you can read uncommitted data in transactions. But this is like the weakest level of isolation. Read committed means you have to be, you know, commit the transaction to be able to read that data. So it only is going to return you the mutated value if you commit the transaction, which is slightly better than read uncommitted. Repeated reads means it's a higher isolation. Repeated reads mean you repeatedly consistently can read the same thing all across. And there's the serializable, which is the highest level, which has a lot to do with like two transactions. If, for example, the transaction A is reading something, I can actually like show you an example of this, because Spanner is doing something called external consistency here, which is very unique to Spanner. Let me figure out what is the best doc for this. There's a visualization somewhere. It must be here. External. Yeah, so this is like clause Spanner's guarantee, which is an external consistency, which means that like, I mean, it does this globally. If you have two transactions reading the same thing and mutating the same thing, if transaction 1 commits before the second transaction reads it, it provides this. So this means like there's like less contention, less locking. You can still, you know, start running this and run this as well, and this is not going to fail. It's going to be able to commit because read A is coming after transaction 1's commit. If this external consistency was not satisfied, then this would have failed. So that is the cool thing, that like, you know, you can do this in a geo-replicated way. And you know, this type of feature has a lot to do, has like proper clocks, which is, you know, Spanner's biggest differentiator. Like it uses something called true time. And there are some white papers on this, and I can briefly go. And there are already like some articles here. But in my article, I also summarized it, which is in a very like simple terms. So true time is interesting because it uses like two different clock sources. There are GPS and atomic clocks, and these are failing for different reasons. That's why it relies on two different sources. And true time, what is interesting about true time is like when you ask what's the time to it, it doesn't return you this is the current timestamp. It tells you the time might be somewhere between this and this. So it gives you some sort of like an interval. And you can say that like if you are not certain what the time is, if you want to have certainty, you can wait until the upper bound. So any spanner instance can do let's wait, let's delay everything just a bit, just to be certain that the time is after this and so on. So there is some latency involved with true time, but they say, according to the white paper they publish, it's not much of a big deal. But it could be a big deal if uncertainty is high. And I don't have any data to actually share anything about this right now, but this is like the interesting part of true time. It returns you an interval, not a specific time. So, time could be anywhere in between, but you can always sacrifice some latency if you are not sure what the time is. So, features like this external consistency is actually a product of having certain timing. So you can, regardless of where these transactions run, I just want to find where the external consistency, even if transaction one is, let's say it's running on a machine, on a data center, transaction two will be able to make this decision because, there's like proper clock sources. So that's the interesting part of Spanner. I mentioned that Spanner has some sort of versioning, which is true that you can go back in time, but this is an hour. If the data is, you have this maximum limit of 1 hour. If the data is more stale than 1 hour, you can't go back in time and read it. This sort of like call is going to fail because it doesn't have the data. There's a garbage collector. Spanner just kind of like goes after things and garbage collect the stale data. That's why there's this like buffer of 1 hour, so you can go back in time, read things, but in an hour, all of that data is going to be gone. Talking about like strong and stale reads, for a very long time I just didn't know what this single is. On the APIs there's a single thing that returns a read-only transaction, and it says that it's like the recommended way, and it says that it's going to use a strong timestamp by default. This means like it's actually going to try to return the latest value. But if you don't need the latest value, you can always apply. You can always create a read-only timestamp, a read-only transaction with a specified timestamp bound. And it looks like this. You basically say, with timestamp, and then you can provide like this is like the maximum staleness I can handle, and so on. Again, like stale data could be useful in certain cases, such as you just want to run some analytics on the data, you just want to read everything, and it doesn't matter if it's like 10 seconds late or something, 10 seconds stale, but that's still useful for you, so you can do stale reads in those cases. There are a few things that I want to do tomorrow. Like, by the way, I was able to find, we have a lot of like documentation on Spanner internally and externally, but I found, and I know like lots of people working on this project, but I found this library to be very like self-exploratory. It gives you the surface layer. It's not like going to explain you how these functionality is being implemented, but I think it's a cool entry point. And to be honest, it's really well documented. We usually are not doing a good job, I think, with documentation, but this is really well documented. I know the Spanner team has spent a lot of time, on their client libraries when they were launching Cloud Spanner. So it was really cool that I liked it. I've been, by the way, working on some additional tools as a side project. There is this a benchmarking tool I've been working on, and so if you're interested in like just seeing how many rows have been scanned in order to serve a query and so on, this is a good benchmarking tool. You have to provide a configuration. It's a YAML file. It's yet another YAML file. You just basically put your connection string here and then give this SQL, as well as you can specify which optimizers you want to use. So it just runs things and gives you the diff. And maybe I can show how this works. Query benchmark. Let me see if I have the yeah. So n here means like just run the queries for 10 times, but like it actually is sort of like by default it's actually 20. But I should do a better job in terms of like just figuring out what is the right time to stop running. There's a question that says like, does Cloud Spanner allow benchmarking? It doesn't, this is like, there's a query planner and some stats available from the client libraries. So you don't have to like run, tons of requests, but you can still prototype things in order to have a, feeling of like the limitations and so on. One thing that I can show you is like on the Go client at least, like there's this analyze query. This takes the query, which is the statement here, and returns you a query plan. The query plan is kind of funny. It has like some nodes and, they have like some display name, some short presentation. I built a simple example reference to consume that plan. Spanner Z is the visualizer that I've written a week ago, and what it does is like basically consuming this API. I can show maybe very briefly. It's somewhere here. It analyzes, this is the query, and then taking the the query plan, creating that dot file, which was in the here. So it just serves like a page like this, and then as soon as you run that query, well, all my examples have this like stupid simple query, but never mind. What it does is actually returns this plan, which is also available on the Cloud Console, but if you want to run this outside of Cloud Console, it's also fine. And it returns these stats. And you can just use it from, I think, any other language client. This is the query planner, by the way, but it also can return some of these stats related to the query. And as you see that like we have multiple optimizers at this point, and we want to the benchmarking tool allows you to basically run against multiple queries, query planners. So in this case, like, for this simple query, I don't have a good setup to actually demonstrate it. I don't know why I'm demonstrating this right now, but in my simple tool, at least you can see the number of rows scanned in both of the query planners, and in, it's like 965 in each, so there's 0% improvement. And then you can see the, the total elapsed time, as well as like the CPU time, some sort of like the planning time. The team has been telling me, the people who were working on the query planner has been telling me that like these numbers are sometimes very noisy, like they are not very consistent with the performance. So the best way to look into these numbers are the number of rows usually. We have an internal version of this tool, which I really want to like, take from there and like keep adding to this tool. So this is kind of like a playground. If anybody needs this, I think I will do some work on it. It doesn't support, it only supports read-only transactions at this point, which is also another shame. I want to do read-write transactions, and I just want to also support like the indexes, and if you want to provide like a specific index to do the query, I should be also supporting that. But yeah, there are like some notes here, and I don't have quite of a roadmap, but if anybody wants to work on this, I'm also happy to brainstorm at least. A couple of years ago, we were also working on instrumenting some of our client libraries, so you must be able to get some introspection through also like distributed traces created in the client library. We don't surface a lot of, backend spans in our distributed traces, but you should be able to see some of the, at least the client side ones. And Spanner client library is actually it's a really fat library. It does so many things. And maybe looking at those traces might also be a good entry point. There's a section about how to enable it, I think, here somewhere. Yeah, it's here. It doesn't really give an example, but I may be able to maybe add an example later. One thing that I want to show was this query with stats. This query with stats is also very cool because it returns a row iterator with stats, and this stats return the stats I've been showing you on this screenshot here, like bytes return, CPU time, bytes read, rows scanned, and so on. This should also provide some support for like read-write queries. It's kind of harder in this context how to do that, but I should at least like support different optimizer versions, as well as maybe some partition queries, or I don't know. There are a bunch of options. Yeah, so generally speaking, I really like this library. Like looking at the index really gives me some sort of like sense what is available on Spanner. It maps to like certain things in traditional DBs, but at the same time it doesn't always match. The concepts on the docs are also, I think, pretty good. Like there are some really almost like white paper like docs. There is a really good doc on life of a query. Maybe I should search. This explains all these, like, the primaries and the secondaries that I've been talking about, and you can get a sense of maybe some of the lower level components, like there's a SQL parser somewhere, and then it just kind of like converts into an AST, and then you have this like subqueries going to the certain leaf servers. I can maybe write more about this type of stuff, like what's going on in this life of a query, because this is a very high level explanation. Oh, I think this is more comprehensive. The reads and the writes are more comprehensive. Yeah, so also this covers a single node write and as well as like a multi-split write. And Spanner allows you to either run things in a multi-regional fashion, or you can start a Spanner instance only regional. If you come to the console, you click on the create instance. For example, you can choose a regional or a multi-regional. Like a regional is also good for development time. Let's say a multi-regional, you can have this like Belgium, Netherlands, North America, Europe, Asia, like different configurations. It's not available everywhere, but you can choose one of the existing region sets. And I think this is probably what I should do, and it gives you kind of like the cost and the storage costs, blah blah. And you need more than one node. There's some node guidance here. It tells you about like some CPU utilization, and you can actually take a look at the CPU utilization from the metrics. And you know, like it talks about the workload, schema design, and dataset characteristics. But we should basically, we're publishing some best practices, but we will do some more work in terms of like releasing introspection tools. So it's not like, you know, it's not a huge black box, because it's just hard to understand what is going on. Yeah, when you press create, it just creates the instance. And then you can create a database, like you can either use this, or you can just basically run the ML query, the schema queries. There's also some Git repo. I've seen a Spanner client library, Cloud Spanner. So they were working on bootstrapping this new organization with a bunch of things. It doesn't even have a logo right now, but there will be probably some other stuff. So they have been, there's a CLI tool, this interactive tool. I haven't tried this before, but you know, you should be able to also create the schema and so on by using this command line tool. It looks cool. I haven't used it yet. It's written in Go. Let's see if they have used the generated libraries or something. I can actually, like, you know, do some contributions to this. This is a library. That's interesting. Separate input. Yeah, they're using this library. It is really cool that they were able to write the whole client library, the whole command line tool by using the the library. That's pretty neat. And you have a history file and everything. That's cool. I'll take a look at this because it looks like they can do some work with readability. I have strong opinions on Go readability, so maybe it's better for me to not take a look. Yeah, 27 per hour is like, there's someone saying like 27 per hour, that's better than BigQuery for revenue. It is really expensive. There are like multiple people who are trying to make it more affordable. So one of the, I think, like, this is my personal opinion, I don't actually have much context on the pricing of this. At Google, there's only one Spanner instance. Like, I mean, there are 3 instances, but there's one for production. So the entire company is actually using one Spanner instance for production. It's built to, scale a large company. One instance should just, should be able to scale. It doesn't scale to very small cases. But there are people who are working on, how to make it more scalable to smaller cases. By the way, there is an emulator going on right now. I haven't checked it out yet, but I should be using that to kind of like give an opinion if it's reliable to at least like build libraries or during the development time. It's a huge problem. It doesn't scale to small companies. I think lots of people, I mean, when I say it doesn't scale to small companies, I would say that it doesn't scale to, I think, hobby projects. There are so many small companies that is starting with Spanner. Let me see. They just released an emulator. I just want to take a look at that at some point. My search is so broken. Must be this. And it doesn't do everything. It does DDL. That's good. Query. It supports read-write and database admin APIs, which is cool. It supports stale timestamps, secondary indexes, commit timestamp, information schema, but there are some limitations. These are the limitations. Yeah, it's definitely not easy to start with Spanner if you just want to use it for a hobby project. Everlag says an emulator would be amazing. Now there's an emulator. This is by the way, a private beta or something. I mean, it's not a private thing, but it's a beta. So if you use this and if you come across any problem, just let me know. I'll share the link in the chat. By the way, be aware of the limitations. There are some limitations. They also support it supports both of the, so Spanner has two APIs. I mean, the same API in two different ways. There's this gRPC API, and then there's the RESTful thing that depends on the gRPC. And it seems like emulator is supporting both, which is cool. The Go client library is using the gRPC one, I think. It doesn't support any persistence. By the way, the other day I've seen another emulator. I'm not sure if it's working at all or not, but it was from a user, and I remember it was saying that it was backed by SQLite. If it's working, like, I think it would be so cool. This Hindu Spanner project. I came across this like just, I don't know, maybe a week ago. I haven't tried it. Oh, it's from Matt. Oh, this is really cool. This might be also something to consider because it has SQLite backed data, so you don't have to lose everything. Not supported. This doesn't have any timestamp bound reads. Doesn't have partition queries. Doesn't have some like full outer joins. Yeah, this seems to be more limited, but it has persistence. And I'm not sure if this is maintained at this point because it's been around, I think, for a while. The latest commit is from 26 days ago. Maybe it's committed. Yeah, both of them have limitations. These are, I mean, emulators are very hard and they just kind of like fall apart from the actual services over time. That's like the most annoying part. What I really wish is like we can at least provide the development, you know, development time database which scales to small cases. I started this other repository of interesting projects. It basically actually captures like all the fundamental things, like reference points. This is what it is. This might be also like interesting if you are looking for pointers. Also, feel free to contribute if you know any other tools. Like I've just been doing some research recently, basically, to kind of like have like a single point of reference. So I came across to like some of these tools as a part of that research. I also realized that we have some configuration management support, which is cool. I haven't looked at these yet, but it's not like I'm going to recreate my instances every other day, but it's nice to have like Terraform support. There is an interesting migration project called Harbor Bridge and this PG adapter. This Harbor Bridge is, it basically takes a PostgreSQL DOM, including schema and data, and it migrates the same schema and data to your Spanner instance. It should be like there are some example usages here. I'm not sure what it supports and what it doesn't. I'm not even, but there's a documentation about like schema conversion, as well as there must be some notes about like what it supports and what it doesn't. But yeah, like it's really comprehensive. You can see the troubleshooting guide and everything. I have only looked at the project for some like reviews. I haven't used it yet myself. And there's this like more adventurous project called this PostgreSQL Adapter, which is trying to basically support the same the Postgres. It takes the Postgres wire protocol and converts things into Spanner calls. So you should be able to use Postgres clients. I mean, the goal of this project is like you should be able to use Postgres client libraries and should be able to use Spanner as a backend. I think it's a very ambitious project, but I'm not sure about the latest thing. Part of the team wants to do is they want to be able to support things more the way the PostgreSQL supports. Overall goal is like more of like trying to converge in terms of tools and in terms of capabilities, I think. Yeah, it's late at night. Maybe I should go and sleep. I haven't done much work today. My internet connection sucked. Like there was a problem, like my upstream was like 5 megabits per second or something. So I decided to just work slightly, just a couple of hours. As soon as my connection got back to normal around like 8. So it was not a very productive day, but I was at least able to, just publish some of my notes, put some of this stuff together. It's interesting that a few people have been asking me like what it feels like to onboard on a new team during this, during the lockdown. I think it's slightly harder, but I work with people I know, so it's easy in terms of having that type of like trust relationship. Plus, people are very knowledgeable, and they always have an answer, and if they don't have any answers, like they at least like have few opinions. So I think like this team is really solid. So I'm very happy about that. I think like otherwise onboarding would be very hard if nobody had any idea what to do or like what I should be working on and so on. I think I gotta go. It's pretty late. See you probably next time. Bye everyone.